So guys, part 7 mein we just did one thing like this. I told to you if possible, but this form is not that much possible. So exact what things are possible I have just given it over here. So for aldohexose C1C5 react to form pyranose, aldopentose C1C4 react to form furanose, ketohexose C2C5 react to form furanose, ketopentose C2C4 react to form furanose. This table, if you remember, you get it. Okay. So from that I have done two examples and kept it for you all so that you all can understand. So if I talk about ribose you will understand it is an aldopentose, so it will react with C1 and C4 and it will form fructose furanose structure. Ketohexose react with C2 and C5 and it will give furanose structure. So that way I have done, you will just can go through it and understand it. Now we'll understand what is mutarotation. Mutarotation kya hai? So what is mutarotation? Now I'm not writing anything, just I'm telling. So this will be blackened. Okay. So basically what is mutarotation? When a monosaccharide is dissolved in water, the optical rotatory power of the solution gradually changes until it reaches an equilibrium value. So when a monosaccharide you are dissolving it in water like amphoteric solution, then the optical rotation power of the solution gradually changes until it reaches an equilibrium value. It continuously keep on decreasing. This change in the value of specific rotation is known as mutarotation. This change in the value of specific rotation is known as mutarotation. Okay. All reducing sugars undergo mutarotation. Example, two anomers of D-glucose have different physical and chemical properties. The values of specific optical rotation for alpha D-glucose is plus 112 and beta D-glucose is 18.7 degree. When either of these pure substances is dissolved in water, the specific optical rotation of the solution slowly changes until it reaches an equilibrium value, uh, 52.7. It results from the formation of equilibrium mixture consisting of 63% of beta anomer and 37% of alpha anomer. The interconversion between these anomers occur via linear form of glucose. So this is mutarotation. I know you need the note. Okay, but first understand it. Then I will give it. Why not? Isn't it? So mutarotation, if I say alpha D glucopyranose solution is there. Suppose. Okay, see now. Alpha D glucopyranose. So this solution is 112 degrees. So 30 minutes it will 100, then after 60 minutes it will plus 80, then this way it will change to 52.7 constant. So monosaccharide dissolved in water, the optical rotation of the solution changes and after some time a constant value it reaches an equilibrium condition. This is called mutarotation. Okay. Now, when I talk about beta D glucose, 19.7, then it goes to 25 after 30 minutes, after 60 minutes, 32. This way it reaches 52.7. So, this is called mutarotation. Now, alpha D glucose is less stable, open structure, where beta D glucose is highly stable, 63%. Okay, it is made. So, why? This is the question. Why beta D glucopyranose highly stable than alpha D? This is the question. This will come cover in the next part of the video. Okay, so this one just you can frame and write. When the monosaccharide is dissolved in water, the optical rotation of this solution changes constantly until it reaches an equilibrium condition. This is called mutarotation. And then you can give an example like alpha D glucose glucopyranose, it is plus 112.2 degree and beta D is 18.7. Both undergoes changes after time and then reaches a constant value 52.7 degrees. This is happens because this is 37%, this is 63%. So there are interconversion between these anomers uh, occurs. Okay, interconversion occurs between two via linear form. So interconversion between these two anomers, you can also write this between two anomers. So interconversion between two anomers occurs via linear form. Therefore, interconversion between these two happens via linear form. Therefore, mutar rotation occurs. This is the cause, this is the example, and this is definition. Definition, example, cause. Okay? Okay, thank you.